look at something called variation. Okay, we have two types that we're going to talk about. The first is direct variation. Okay, so we could say that two variables x and y show direct variation if y equals k times x. Okay, where k is the constant of variation. Okay, inverse variation. Let's say we have two variables y and x. Those are related with inverse variation if y equals k divided by x, and k is still your constant of variation. Okay, let's talk about what these might look like. First of all, let's talk about classifying these. Okay, deciding whether or not we have direct, inverse, or neither. Okay, so let's look at a couple quick examples. Let's say we have y divided by 5 equals x. Now, that doesn't look like our original y equals something times x or y equals something divided by x, but let's think about if we could manipulate this. If we could change it around, could it look like those? Okay, if we multiplied each side by 5, for example, we could say that this is y equals 5x. In this case, it looks like direct variation because we have y equals k times x. In this case, the k is 5. Let's try another one. Let's say that we have y equals x over 2. Okay. This one actually ends up being direct, but a lot of times people get confused and say, well, it's not because you have x divided by something. Think about how you could rewrite this. X divided by 2, we could say is the same as 1/2 x. Okay, 1/2 times x. That's an equivalent expression. So that is still direct variation because we have a number times x. Okay, let's take a look at a couple more. Let's say we have y equals x plus 2. Okay, that does not fit at all with either model. That doesn't have a number times x. It doesn't have a number divided by x. And there's no way to rewrite that. The only thing we could do is subtract it over, but that 2 is then going to be subtracted from the y, and it's still not going to fit with either of our types of variation. So this one would be neither. Okay. Let's try one more. Let's say we have x times y equals 4. Okay, when we first see this one, your instinct might be to say, well, that's neither because that doesn't fit each one. But again, think about trying to simplify this or move it around and play with it to get it to look like the others. If we just divided by x on both sides, we would end up with y equals 4 over x. Notice this one now looks like inverse variation because we have a number divided by x. Okay. If you have any problems like this where they are asking you to classify, is it direct, inverse, or neither? They should be pretty easy, but the big thing you have to realize is you may have to play around with the equations, just like we did. On most of these, we had to manipulate them a little bit to make them look like the form. Okay. So just don't be afraid to do that. Okay. Don't be afraid to rewrite it in a different form and see if it looks like one of those variations. Okay, let's talk about what the problems might look like. Okay, let's say that we have y varies directly as x with y equal to 12 when x equals 4. Okay, and let's say the first thing they want us to do is find the constant of variation. Okay, well, let's think about our equation. We said direct variation is y equals k times x, right? So let's plug in what we know. Y is 12, k is what we're solving for, x is 4. Okay, if we have k times 4, then to get rid of the 4, we need to divide. 12 divided by 4 gives us 3, so k is equal to 3. Now, let's think about what that means. Okay, that means we could rewrite this equation as y equals 3x. And then a lot of times they'll ask you to make a prediction. Okay, they may say for part B, or this may be the entire problem, maybe they didn't ask you for the constants of variation, but they may ask you find the value of y when x equals 3. Okay, so we just said that y equals 3x, right? That was the equation that we wrote once we found the constant of variation. So let's plug in y equals 3 times 3. So y equals 9 in this case. And again, sometimes they won't ask you to find the constant of variation. Maybe they'll just go straight to find the value of y when x equals 3. Let's take a look at one like that, and we'll do it as an inverse so that we practice both types. Okay, so let's say that they tell us that y varies inversely as x with y equal to 8 when x equals 3. If x equals -4, then y equals what? Okay, so let's think about this problem. Okay, they took it a step further. They didn't ask us to find that constant of variation first, but that's what we're going to have to do. Think about what we wrote for inverse variation. Y equals k divided by x. Let's plug in what we know. Y equals, oops, well, silly me, I forgot the y. Y was 8 equals k divided by x, which was 3. If we want to solve for k, we need to multiply by 3. Okay, so 24 equals k. Now we know that y equals 24 divided by x for this problem. Okay, we found the value of k. So let's take a look at the second part. If x equals -4, then y equals what? So let's plug in what we know. 24 divided by x, which is -4. 24 divided by -4 is -6. If I could write, that'd be great. There we go. So y equals -6. Okay. Now, the only time that this might get a little bit more confusing is when we're not necessarily using y and x. We may be using different variables. Let's say that they tell us that time varies inversely as average speed. If it takes, let's come up with something. Let's say if it takes 4 hours traveling at a speed of 45 miles per hour, how long would it take traveling 36 miles per hour? Okay, so whenever I see a problem like this, I go ahead and give different variables. So let's say time is t, and let's say average speed is s. Okay, so let's think about what they told us. Time varies inversely as average speed. Always go in the order. Okay, we said y varies inversely with x, and that was y equals k divided by x. So if time varies inversely as average speed, that's t equals k over s. Okay, now let's plug in what we know. The time was 4 hours, and the average speed was 45. So in order to find the k, we need to multiply, okay, 45 times 4 is going to give us 180. So the k is 180. Now it wants to know how long would it take traveling 36 miles per hour. Okay, we just said the k is 180. So we know that t equals 180 divided by s. Okay, they gave us a new s. The new s is 36. So in order to solve for the time t, we want to plug in 36 for the s, the speed. So 180 divided by 36 will give us 5 hours. Okay. Now, word problems like this are pretty common, but they should be very easy as long as you follow, like I said, exactly the way it goes. Time varies inversely as speed, so that's why I start with my t equals k over s. Okay. If it had been the other way around, we would have switched it. You go in the order that it gives it to you. Okay, and then you just set up your word problems, set up your equations, either direct or inverse variation, depending on which type you have. You guys are going to have quite a few practice problems on this, so please feel free to reach out to me if you're having difficulty, and I will help you.